Hey dev team, welcome back to Flutter with Dry. We're going to do the big one today. I didn't want to be a tease and hold off on the graph until the very last episode. We're going to actually tackle that one today, get that done, and then in the next episode we will probably have enough time to finish the rest of the bits off, which are just really layout bits, and do any tidying up that needs to be done. So let's get straight into this and create our animated graph. Right, so I'm in my graph.dart file and we're going to be working almost exclusively in this file today. So I am going to close my file list on the left hand side there, give ourselves as much room as possible, and let's get cracking. So we've got an expanded and now we need to put our graph into there. We put this in an expanded because we want our graph to take up however much room is available for it. So I'm going to change this container first of all to a sized box because we don't need it to be a container. We don't need to put a color in it, and we need the width to be the double infinity, and we don't need a height because, as I say, it's going to take whatever size it's going to take. And we're going to put into there a child which we're going to call graph area. And this is a widget that we're going to create now. And we're going to create it below. Now this widget needs to be a stateful widget because, well, that'll become clearer later on with the animation, but with the animation it does need to be that. So we might as well create it as that from the get-go. So we've got a stateful widget, which is the graph area, and that's being called in from there. So a quick save of that, and our area is clear and ready for us to go. Now this graph is going to have to take data, and where this data is going to come from, goodness only knows. We'll assume that it's coming in from some offline database, but we're going to have some data points. So I'm actually under the very bottom of all of this going to create an object called data point, and that data point will have 2 bits of information for now, an integer which is the day and a final integer which is the number of steps that person has taken. And those are the information we're going to use to create our graph. So let's set that up, and both of those are going to be required. So required this.day and required this.steps. And that gives us the flexibility to increase the data that's in here sometime in the future should the app be expanded upon. Okay, next we need to create the data. So in our graph area state class for the override, we're going to create a list of data points which we're going to call data. And we're going to put into here our data points. And so we're going to have steps 1. And instead of putting in the number of steps, we're going to randomize this. So we're going to use Dart Math again, and we're going to put random dot next int, and I'm just going to put 100 in there, and I'm going to copy that 8 times and just change the day from 1 to 8. Okay, so ordinarily that would come from some sort of database, come from somewhere, wouldn't necessarily be hard coded into the app, but what we do now have is a list of data points which has a random number for each data point, and we're going to use that information to build our graph. So let's come down to our build And instead of returning a function, we're going to do exactly the same as we did for the header in the first episode, and we're going to return a custom paint. And that custom paint has to have a painter, and that painter is going to be, we'll call it our graph painter, and of course that doesn't exist yet. So just above our data points, let's create that class graph painter, and this extends custom painter. Hovering over this, control dot, we can create our two missing overrides like we did before, the paint and the should repaint. For now, I'm going to change the should repaint to just return true, and we will, while we're developing, we'll come back and fix that up to make it more efficient once our development is done. And we need to now implement the paint. So the first thing this custom painter is going to need to know is our data. So we're going to have to pass that in. So final list data points, data. We need to create a constructor for the final fields, and we've got this data. Let's put it in our named convention and put required, because it is required. Up above now we've got this red line which says there's something missing. What's missing is the data. We're not passing the data in, so let's just do that. Quick save, and we're ready to go. So most of what we're going to do now is going to be within this paint method, because what we need to do is paint the graph. Now to do that we need to work out some information first of all. We're going to have the days going along the x-axis, and so we need to work out the spacing between each of the days. Let me give you an example. Let's say that this I represents the edge of the screen, and so right next to the edge of the screen we're going to have our first data point, and we've got 8 data points altogether, so we're going to have 1, 2, 3, 4, 5, 6, 7, 8, and the other edge of the screen. So we know that on the x-axis the first data point is going to be 0 because it's the edge of the screen, and the last of the data point is going to be whatever the width of the screen is. But we need to find the positions for all these other ones, and to do that we need to find the spacing between them. Now we'll see that there's 7 spaces, 1, 2, 3, 4, 5, 6, 7, which is 1 less than the number of data points. So we can create a variable called x spacing. That sounds good. And that is going to be the width of the screen divided by 7, and we can work out 7 by taking the data length, which is 8, and subtracting 1 from it. So however long our data, however big our data is, then this will give us the exact spacing we need in between each data point on the x-axis. Okay. The next thing we need to do is work out the height. So we've got, let's just say for our example that the first one is randomly given 10 steps, and the second one is randomly given 20, 30, 40, all the way up to 80 steps. We need to find out which of these is the highest point, which of these is the highest number, because that is going to be the top of our graph and everything else is going to be underneath it. Now we're having numbers here 1 to 100, or 0 to 100 in fact, but number of steps in a day can go into thousands, and if this was a financial app it could be thousands or even millions, the numbers. So we don't know the size of that, so we need to work it out. So what we're going to do is we're going to write a function that goes through each of the data points that we've got and compares it to a previous one to see whether we've got a maximum, see whether it's the highest, and we'll end up with the highest number of steps. So we're going to say var max steps is going to equal our data, which we're going to fold. Now, if we look at fold, we can see that it takes, oh, hang on, I can't get it to stick. It takes an initial value and then a function that it does something against, the previous value and the current element. This will make sense as we go along. So the initial value we're just going to set at being the first data point, data 0, so the 0th item in our list. I'm going to change P and element to C, so we've got our previous element and our current element. And just to help with code completion, we're going to tell Flutter or Dart what it is that these elements are and their data points. And so what we're going to do is we're going to say from the previous steps, is that greater than the current steps? So is this one greater than this one? If it is greater, yeah, if the previous one is greater, then return the previous. Otherwise, return the current. So out of the two that it's comparing, whichever one is the maximum is going to get sent back. And what we're going to do is get the steps out of that. So this here is returning a data point which has the highest number of steps, and then once that's done we're just calling out the steps. So if we print out here x spacing and max steps and save that, we can see that the spacing in between each of our data points on the x-axis is going to be 58, and the maximum number of steps we've got is 75, so that the maximum of all those was 75. If we refresh that, that number should stay the same because our screen size isn't changing, but that will change. Let's have a look. Okay, and so in this case we've got the max steps of 94. Now we know the max steps, we can work out what the y ratio is, what each step, how high each step should be. And we can do that by creating another variable called y ratio. And the y ratio is going to be the size height. So how high is this graph area divided by the maximum number of steps. And now we know for each step how much space we have to give it on our y-axis. So we've got our x-axis and we've got our y-axis number. Excellent. Now those are the two major numbers we need. We can now start looking at creating our line. So as we did in the first one, we're going to need a paint. And I'm going to call this line paint. And we're going to make this into a paint with, for now, a colour of black while we create it all. And we'll also give it a width, stroke width of 3. Yeah. Okay, so that's our line. And so like we did before, we put and drew circles. Well, this time we're going to create a path. So we need to, for all of our data points, we need to work out the offset that it's going to be. So if you remember, actually let's do this. If we say path we create a path, which we'll call line path equals a path. And what we're going to do is we're going to take our line path and we're going to move that to 0, 0 position. And then we're going to take a line path and we're going to line to the size.width and the size.height. That in itself does nothing. When you've got a path, we have to draw it. And we can draw a path onto the screen by using the canvas.draw path. So if you remember in the past, we've drawn a rectangle and a circle. This time we're drawing a path. That takes the path, which is the line path, and a paint, which is the line paint, and that should give us a diagonal line across the screen. And that gives us nothing. And that's because we're drawing a straight line at the moment, and a path needs to complete. We can fix that just by coming up to our paint and adding in a style and changing the style to a painting style instead of fill, which is the default, to stroke. And if we save that, there we are, we have our line across the screen. So we know our canvas is working, we know that's all working. All we need to do now is work out the points. So let's do that. What we have to do is convert our data points that we've got into a list of offsets. So instead of putting the offsets in like that, because those are just offsets, they're going to be the positions on the graph. So to do that, we're going to create a list of offsets, which we're going to call offsets, and we'll initialize that to an empty list. Okay, so what we're going to do is we're going to go through all of our data points and change it, the values, into an offset. So to do that, we're going to create a loop. So for int I equals 0, start at 0, while I is less than the length of our data, so data.length, I++. So this loop is going to circle around for all our data points. And we can do offset.add offset x and y. Now the question is, what are these x and y's? Well, the x we've worked out already. The x starts at 0 because on the left hand of the screen, and for each one it's the spacing. So if we start off outside our loop, if we make a variable called cx, which means current x, and set that to be 0, we can then put our offset at the current x position, and after we've gone round the loop, we can add current x plus equals the x spacing. Now if you're not familiar with this plus equals notation, that's exactly the same as typing current x equals current x plus x spacing. Whoop, that's not x spacing, x spacing. Those two lines are identical in what they do. This just takes the variable and adds to it. Okay, so that's our x taken care of. What about our y? Well, we need to work that out. So what we're going to do is we're just going to create another variable here called y, and y is going to be equal to the number of steps, so the data in index I steps multiplied by the y ratio that we calculated. So if the maximum number was 100, and that been worked out, and our screen space was 200 high, our y ratio is 200 divided by 100, which is 2, and so y is going to equal 100 times 2, which is 200. So that's going to put it at 200. But the problem is, as you can see from our graph that's already drawn, the end of the screen is the height, because we'd set the bottom right hand side of that to be the height. So basically the numbering starts at the top and works its way down. We want it to be from the bottom to work its way up. So what we need to do is we need to take the total height and subtract that formula that we've just created from the total height, and that will invert it the other way around, and that gives us our offsets. So now when we come back down here, initially what we need to do is move to a particular offset and then line to all the rest. To do that, we need to know the current offset that we're at. So we're going to create a new variable called current offset, and to start with, that is going to equal the first offset in our data point. So from our list of offsets, we're going to take the first one, because that's always going to be on the left hand side. So that's where we want to move to. So we're going to move to the current offset dot x and the current offset dot double y. So that has taken our line and has moved it to the first point. And if we save that, we will see, if we refresh everything, that our graph is now redrawn from where the first point is to the bottom right hand side. Okay, now instead of the bottom right hand side, we need to move to somewhere else, and so again we're going to have to go around a loop, because we're going to need to move to a number of points. So let's create another loop, and we're going to say for, and this time we're going to say int I equals 1, because we've already taken care of the 0th element, so we don't want to move there again. So we've dealt with that index. While I is less than, this time we're doing the offsets, so offsets.length I plus plus. So we've got our loop, and what do we want to do in that loop? Well, each time we want to move to the offset. So let's take our line 2, and instead of size.width, we're going to get it a variable x, and that's going to equal to the offset I x position, and the same for the y position, and then we can move to those positions x and y, and so that's going to go round the rest of our data points and then draw the path. Let's save that, and there we have, there's our path. So you're wondering why we've created this current offset. Well, we'll come to that in a moment. But there is our graph, and that's working. And every time we refresh this, because we've got random numbers, we'll get a different graph each time. So that's a good start, but it's all pointy and jagged and not at all smooth and nice like our design. So how do we smooth this out? Well, unfortunately, we're going to have to use a bit of maths and have a bit of curves. And I'm going to preface this by saying I am no expert when it comes to trigonometry and curves and what have you. There may very well be a better formula for doing this than I'm about to put in, but what I'm doing works, so I'm happy with it. To do this, we need to understand the curve a little bit, and so I have found this website. Now this website gives us this curve, which is the black line, and it also gives us these extra points, which we'll come to in a moment. But let's assume that on our line we have a curve that starts from 0, 8 and goes to 8, 0. These two extra points dictate how the curve is made up. And we need to do something that makes our curve always look smooth. So, for example, that would not make sense. Having that would not make sense, because when we went to the next curve, it would be all over the place. So just by playing around with this, I've worked out that what I want to do is something like this, where the two control points between the offsets are somewhere in the middle and gives us a nice smooth curve. So I've played around with a few formulas, and this is the one that we're going to use. So when we're talking about control points, it's these points that we're talking about. Obviously the data points or our offsets remain where they were the whole time. But you can come here and you can find out a different way of doing it if you wanted. Right, so let's get back to our code. And to do this, I'm going to come back up to our Y ratio, and I want to find what I'm going to call the curve offset. And that is the space between the control point that I've just shown you and the data point. We don't want the control point to be further on the x-axis than our next data point. So x spacing has to be the maximum, and I'm going to go with 0.3, so about 30%. So it's not quite halfway between the two, that would be 0.5, but this is a number that you can fiddle with until you get something you quite like the look of, as long as it's not above 1. Okay, so back down to where we've got our line 2. And this time, instead of line 2, we're going to change this to cubic 2. And cubic 2 takes a lot of numbers. We have basically, if I can get that back, we have the first set of offsets, x1 and y1, which is the first data point, and x2 and y2, which is the second data point, and x3 and y3, which is the actual data point that we want to put it on. So 2 control points and a data point. So let's just be clear about this. We're going to have a control point 1 x, a control point 1 y, a control point 2 x, and a control point 2 y, and then the x and y of our data points. So these are the bits we need to do the calculation for. Now let's do that and set up the control point 1x is going to equal the current offset. So what is the current data point? X value minus the curve offset that we've just set. The C 1y is going to be equal to the current offset y. Because as you saw in the demo that I did on the thing, I've kept the y position at the same level. The cx2 is going to be equal to the current x minus the curve offset. And we don't really need to put this in, but sorry, it's not cx2, it's c2x. c2y is simply going to be y. So that's sort of like a wasted thing because we could just put y there, but so you can see each of the data points, each of the calculations we're doing, left it like that. Then, once we've created the path, we need to update the current offset so the next time round it's got the right value. So we do c offset equals the current offset, so the offset at the current index. Now when we save that, we have chaos. That's because that should be a plus, not a minus. Typo. Okay, let's save that. There we go. And there we have our smooth graph. So I was moving the control point to the wrong side. Okay, that's looking good, but that's not what the graph looks like. The graph is actually a shaded area. So we need to do that. So after we've drawn the path, or sorry, before we've drawn the path even, we need to close the line off. We've got the line that is being drawn to here. We now need to bring the path down to this point, and then to this point, and then to close it, and then we need to fill this area. But we also need the line as well. So the way we're going to do this is we're going to create a new path, which we're going to call the fill path, and we're going to take the current path and that will be the basis of our fill path. So at this point, our fill path and our line path are exactly the same, but they are two different paths. So I'm now going to take the fill path and I'm going to draw a line to the size width and the size dot height, and that will automatically take it down to the bottom right hand side. We then need to take the fill path and do a line to, and this time we're going to the 0 size dot height, which takes it to the bottom left of the screen, and because the path is going to be a fill, it'll automatically close, so it will automatically get itself back to the start. So to paint that, we're going to have to do a paint. So let's copy our line paint, and this time we're going to call this fill paint, and we'll change the colour to just blue for now. And instead of being a stroke, painting style stroke, it's going to be painting style fill, and we don't need a stroke width in that case. So because we want our line to be on top, we'll draw that second. So before that, we're going to do canvas dot draw path, and we're going to draw the fill path, and we're going to use the fill paint. And when we save that, we have our blue in. Now we're getting somewhere, but in our design it goes from a solid colour at the top down to white. So let's come back up to our fill paint, and We're going to get rid of color in a second. Instead of putting a color, we're going to create a shader. And we're going to create a shader, which is UI, which we need to import. So if we come up to our top, under Dart Math, we're going to import Dart UI as UI, so that we can reference it as UI within our code. So back down here, we've got UI, gradient, linear, and we can put a from and a to and the colors. So where do we want it from? Well, let's just put, these are offsets again, let's just put offset 0, 0 for now, and the 2 is going to be an offset. This is not the design, we'll come back and fix this in a minute. Size.width, size.height. Okay, and then the colors that we want our gradient to be, which is a list of colors. And for us, we're going to go from color 0xFF 30 C3 F9 0, and the color we're going to is color.white. Let's see what that does. Okay, so that has put our gradient in, but it's not quite going the way we want it to. So let's think about it. We want it going from blue at the top down to white at the bottom. So we have to change our offsets so that this is in the middle at the top, and we can do that with size.width divided by 2. And we're going to the middle at the bottom, so that's size width divided by 2, size height. Save that, and now we have our gradient going from top to bottom. We can now change the colour of our black line, because that doesn't match the design either, and we can change that to colour 0xFF, and it's going to be the same colour as the top of our graph. So we can just copy that and paste it in. That's the quickest way of doing that. Okay, now why have we put something that's the same colour as the top of the graph? Well, you might not be able to see it clearly on YouTube, but the line also has a sort of shadow under it, a white shadow, and so we're going to put that in as well, and we're going to do that by copying our line paint, creating another paint which we're going to call shadow paint. The colour for that is going to be colors.white, and after we've drawn our before we've drawn our line, we're going to draw the path again, but this time with the shadow paint. But that just paints a white line underneath the blue line, and we can't see it. But if we come up to our paint for our shadow paint and also add in mask filter, we can put in a mask filter blur. We can put a blur type of solid and a sigma of 3, and if we save that, we've now got that nice white shadow underneath our line, and that is as the design. So that's our graph done. All we need to do now is animate it. Okay, so to do that we need to come up to the graph painter, above the graph painter, our graph area state widget. And within there, we need to create an animation controller. Now, an animation controller is an object that, as the name suggests, controls the animation, how long it is, when it starts, when it stops, all sorts of stuff. It's complaining here, though, that it isn't used and also must be initialized. So we need to make sure that that is initialized. And within a stateful widget, we can do that with the init state override. The init state is called when the state is initialized, and it allows us to set stuff up. So we need to call super init state at that calls the init state that's part of the stateful widget, and that's all needed. And then we can do whatever we want to do, and what we want to do is set our animation controller to equal an animation controller. Now that requires this thing called a vsync, and without getting into too much details about animations, it's essentially a ticker. It tells the animation a lot of information about the refresh rate of screens, all sorts of stuff. We need to code all that. Thankfully, that's been done for us, and we can get this, we can turn this state, this graph area state, into a ticker by calling with single ticker provider state mixin, and that turns this whole state into a state with a ticker. And then for our vsync, we can just pass this into it, this being the state. The other thing we can do is set a duration. How long do we want the animation to last? Well, let's set a duration of maybe not days, that might be a bit too much. Let's go with 2 seconds for now. Right, so we have this animation controller. It's still complaining at us because as far as Dart's concerned, this could be null. So we're going to put the late keyword in the beginning there, which says we promise we're going to set you up before we use it, so you won't be null. And we've fulfilled that promise already with our init state. To be good developers, we should also make sure we call the dispose of the widget. So when the widget is cleared, shut down, removed from memory, this code is called, and we can do all our tidy up. And one of the things we want to do here, if we've created a controller, is make sure we call dispose of that controller as well, so that when this widget ceases to be, we're going to make sure that all the code that's already built into the animation controller to dispose of it properly, you know, to stop the animation, free up memory and everything else, is called. So that's the housekeeping done. We now need to pass that animation value. So when the animation starts, it's basically going to have a little value for us that we can pass, which is the percentage of how far the animation is complete. So over the 2 seconds time, at the beginning, that value is going to be 0, and by the time it gets to the end, it's going to be 100%, it's going to be 1. So we're going to have to pass the data, that animation value, to the graph painter. So just before the curly brackets here, let's say we're going to expect you to pass in an animation called animation. At the top here then we can pass that in by putting in our animation controller, and it's not just the animation, we're not passing in the whole animation, we only want to pass in the view, which is if we look at the description, it is an animation double for that animation controller. It's a pointer. This object can be passed around without using pointers to mutate the animation controller state. So basically, the animation controller lives and all the work is done within our stateful widget. And all we're doing is passing this animation double to our graph painter. So in our graph painter, let's be clear about that. That's what it's passing in, so that's what we'll put, animation double. So within our animation, we're going to want to, within our graph painter, we're going to want to use that number. We could use that number directly, but I'm going to do it in a slightly different way because of reasons I'll explain later. Okay, so we're going to create a final animation double, which I'm going to call underscore size because it's going to be private to the painter. So we are using an animation, but I'm changing it there, and I'll explain why after. But we need to set that up, and we can do that by, before our semicolon at the end of the line, setting up that size equals a tween double, which takes a begin number of 0 and an end of 1, and we're going to animate that with the animation that we've just passed in. Okay, what does all that mean? Ignore the fact it's all gone red. We'll come back to that in a second. Let's look at this line and explain this. Well, a tween basically takes a number, it changes between 0 and 1. So we've got here a double, so we're talking about doubles here. We've got a 0 and a 1, and we're passing in the animation. So that means that at 0% of the animation complete, at the very beginning, this tween double is going to be 0, and at 100% it's going to be 1, and then at 50% then it's going to be 0.5. The tween works out the difference. Now tween is useful because we don't just have to use doubles there. We could have put, for example, colour, and we could put a colour of begin red, end a colour of green, and the tween would tween between the two. So at the beginning it would be a red colour, at the end it would be a green colour, and at some point it sort of morphs. It's like a morph, it goes between and would be whatever colour is between green and red. I hope that makes sense. We're just using it as a number for now. Now the reason it's gone red in our emulator is because the stateful widget is only, the onInit is only called when the stateful widget is first initialized, and we've not called initialized previously. So to get that to work, we're going to have to do a hot restart. Let's do that, and that should return our graph to the normal state, but it's not being animated yet. So how do we animate it? Well, we now have, over the course of an animation, this size, which is 0 at the beginning and 1 at the end. So effectively we can use that as the percentage of the height of our line. So take this point here. At the beginning of our animation we want it to be down here, and over the 2 seconds we want it to grow to this point. Same with all the other points. So what we can do is come down to where we calculate where our data point is, where the offset is for that point, and just multiply that by the size and the value. So size is the animation double, and the value is the current value of that animation double. So that at the beginning is 0 and at the end is 1. So at the beginning, any number, whatever that has been calculated to, multiplied by 0 is 0. So that's going to give us the 0. And because we've got size.height, we've taken the height of our screen, subtracting that, or subtracting 0 from that, that will give us the very bottom, putting the line at the bottom. And then as our animation progresses over time, then this value will eventually change to 1. And so supposing this calculation comes out at the value of 250, well 250 times by 1 is 250, and that will give us the top of our graph. Okay, so what happens when we refresh? Well, you'll be surprised to see we got nothing. We have got a faint line all the way along the bottom. So part of that's working, but it's not very animated. And the reason for that is the animation controller hasn't started yet. It's set up, it's ready to go, but we need to make it start. And in our case, it might as well start as it's initialized as well. So we can take our animation controller and call forward, which will start the animation running forward for us. So if we save that now and reload our screen, we get nothing. Okay, why are we getting nothing? Well, our graph painter doesn't know it needs to repaint. We're not giving it any instruction. We can do that here at the end of the animation. We can come in and we can call super repaint animation, and that means that will basically instruct our graph painter to watch this animation, and whenever the animation values change, which will be during the course of the animation, we're going to repaint it. We're going to call the repaint. Right, now we can save that and refresh, and there is our graph being built over the 2 seconds. Let's refresh again. There, perfect. Now I would like it, just for demo purposes, to be able to click on the animation, or to click on the graph, and for the animation to repaint. So I'm going to come up to our graph area where we have our custom paint, and I'm going to wrap that with a widget, and we're going to wrap it with a gesture detector. On tap, and what function do we want to do? Well, we want our animation controller to go forward. Now, when we click on that, nothing will happen because it's already got to the end of the animation. It's got nowhere else to go. So what we can do within the forward is we can say from what point in the animation do we want it to go forward, and we want it to go forward from 0. Yeah, if we put 0.5, it would go from the 1 second mark, but we're going from the beginning, 0. So when we refresh that, now when we click on our graph, it'll be rebuilt. And of course the data points don't change because we're not changing the data points, we're not rebuilding the widget, we're just restarting the animation. Okay, now the animation grows and it's a very linear growth, it's continuing the same speed. We can apply a curve to our animation and make it a little bit more interesting visually. So let's come back down to where we've got our size, and this is why I didn't just want to put the animation value here, because I knew we were going to change this a little bit more. So we're going to animate it, and instead of passing in just the animation, we're going to pass in a new curved animation. So the curved animation takes a parent animation, and that is going to be the animation that we're passing in, and it also takes a curve, and a curve is a formula essentially to how we want the animation to work, and there's quite a lot that are built into it. If we put curves, we can see we've got animations to do with bouncing in, bouncing out. There's all sorts of things to play with: linear, slow to middle, elastic, fast in, fast out. The in being the beginning of an animation and the out being the end of an animation. I'm going to go, I did play around and I decided I wanted to go with this ease in, out, cubic emphasized. And when we save that and reload it, you can see now that our animation starts really quite quick and then gets nice and slow towards the end. I think that looks a lot better. And that's the reason why size is different, because size now is no longer the same value as the animation value. It's going through another set of calculations. Okay, so the last point of this now is in our design you can see that there's a little dot circle over an area of the graph, presumably who knows what the designer thinks that meant, but we want to put that in as well. So let's do that. I'm going to come below our paint because we're going to have to put in a couple more paints. So the first one we're going to put in, I'm going to call it dot outline paint, and that is going to equal a paint with color equals colors dot white. I think that will do for now. We're going to want the width of that as well, so we're going to put a stroke width of 8. No, not 98, 8. Okay. And then the other one is for the center of that dot, which is going to be the same color as our line, but it's going to have a much bigger stroke. So we're going to put this as paint dot center equals paint, and the color is going to equal this same color that we've been using. So I'm just going to copy and paste that, and again the stroke width is going to be 8. I'm sure I put 8 above and it's turned to 9. Okay. So those are our paints. Let's come down to where we're going to want to draw it, which is after our paths. So we're going to put canvas dot draw circle. Where are we going to draw this circle? Well, we're going to put it on the 4th offset. So out of our offsets, whichever one is the 4th, that's where it's going to go. How big do we want it? The radius, well, I'm going to say 15, and the paint is going to be the dot outline paint, and then we're going to copy that line, same offset but a smaller circle, and that one's going to be the dot center. Alright, let's refresh that, and there's our dot. Doesn't quite look like the design. So the white shouldn't be solid, so we'll come back up to the white here and we will change the color to have an alpha, and we'll put in 200 there. I think that looks okay. Let's look what happens when we redraw the graph. Well, the dot point moves because we're recalculating it, but I would like the dot to appear after the graph is drawn. So how could we do that? Well, let's put in at the top here where we've got our animation double size, let's put in another animation double which we'll call dot size. And just like we've created the size tween, I'm going to copy that identically for a moment, paste it in, and this is going to be the dot size tween. Now, yes, at the moment they're the same thing, but they're not going to be in a minute. Coming back down to our dots, let's multiply the radius by the dot size, dot value, of both the inner and the outer part of that dot. Save that, and now that gives us the animation where the dot grows, and that might look alright, you might be happy with that, but I'm not. I want that to happen mostly after the graph is built. So let's come back up to our curved animations here, and let me just put a few commas in just to change the formatting so we can see what's happening. So instead we've got two curves that are the same, they're great, but what we want to happen is this size animation needs to happen over the first, let's say 75% of the animation total, and then the last 25% the dot size is going to change. That's what I'd like to happen, and we can do that by changing the curves to, instead of a curved and then one of the defined curves, we can change that to an interval curve. That takes a beginning and an end. So this particular one, I want it to begin at the very start of our animation, and I want it to end 75% of the way through our animation. But I also want this to have the curve, and I want this to have the curves that we've had before, the ease out, in out cubic emphasized. And that basically does all the calculations to make sure that this runs only over the first 75% of the whole animation. If we copy that line and paste it here, now this one happens over the first 75 as well. That's not what we want. What we want to do is change that to start at the 75 and run until the end of the animation. So now when we refresh our animation, you see that that pops in afterwards. So as soon as our animation is 75% of the way complete, our 2 seconds is complete, then that runs in. Now, if we want the animation to last a little bit longer, let's come up to where we set the duration. Let's put not seconds, milliseconds, and let's set that to 2500, which is our 2.5 seconds. And now we'll need to do a hot restart on that. Now we have our dot, the animation still taking 75% of 2.5 seconds, and then after that the dot moves in. If we wanted that to start while the animation is completing, we could. All we'd have to do is start that at another point, so maybe 0.5, and then that dot will start drawing before the other animation has finished. But that's up to you and how you would like that to look. But folks, that is our graph animated. That's been a big one, so we're going to leave it there. I hope you've enjoyed. If you have, do leave a like and subscribe, that does help me out, and we will look at finishing the rest of this app next time. Hit that notification button to be notified of that, and we'll see you then. Alright folks, take care. Bye now.